Hi everyone, in this video we'll review the subject of pointers in C. We'll get to know what are pointers, the syntax, and how to do operations with them. First of all, a pointer is a derived data type used to store the address of a variable. Unlike a normal variable that stores a different value at a given time, the pointer will not store the value of that variable, but actually the address that it occupies in memory. This will allow us to access indirectly to the value stored in that variable. So for instance, according to the address that we have in that pointer, we will go and search what's the value in that address. This doesn't seem like useful at the first sight. However, this will allow us, in the same way that a variable can change the value that it holds, the pointer can also change the address that it holds inside. So this will allow us, since I told you that we can access indirectly to that variable's value, as the same way that we change the address, we will be able to change the value, or actually the variable that we are accessing. So a pointer can change the address every time as much as we need in our program, thus allowing us to switch between several variables and manipulate the different values that all of them have. So let's start, for instance, with a regular data type. As you can see, it occupies a space in memory. We name it and then we give it a value, okay? This will occupy a particular address in memory, okay? So we have value, name, and this address, okay? How do we refer in our program to this variable? By its name, okay? However, a pointer data type will have the following representation. It also occupies an address in memory. We can give it a name. However, it does not store here a normal value like the other ones, but actually an address. So this address will allow us to indirectly, by managing this pointer, to access the value in this variable. As you can see, this variable has this same memory address that is contained within this pointer data type. So this pointer, and this is why it has its this name, is pointing to this variable here in this address, okay? And we will allow us to manipulate this value here. So let's say, for instance, that we have an integer variable called h, and we give it a value of 25. This is the address of our variable in memory. As you can see, it is a long hexadecimal number, which is the memory address for this variable, integer variable, okay? So the pointer to such variable would be this one. We can also give it a name, p, and then we will store here the address of a variable. Which one? Well, in this case, this one. So this pointer has a particular address in memory, but also it stores only addresses values, okay? In this case, this address points to this value here, which is h, with a value of 25. And this one is the address contained here inside the pointer. So remember that different data types have different sizes. For instance, this one is 4 bytes, meaning that it is a integer variable, for instance. And since this one is the address from 03 in hexadecimal, we will have the following representation for a pointer. This will be the pointer pointing to that particular address in memory, in which I can find my data, my integer datum, okay? which is 4 bytes long. As we saw in the previous video of arrays, we to access the different elements within an array, we will use the name of the array and this index in these square brackets. So if I want to access the first element, let's suppose that this block of data is an array. To access the first value, I will have to use the index 0. For the next value will be the index 1. So as you can see, you can consider a pointer to be something similar like the index of an array, because here you place the number of the datum that you want to access within this array. However, you cannot surpass the boundaries of this array. Okay. However, the main difference is that this one, the pointer, will allow us to change what's the address we are accessing, but not only within an array, but actually within the whole memory that the operating system or the computer has granted or programmed to manipulate. Okay, so you can move along all of the block of memory available for your program by changing the address here. Okay. Okay, so what's the syntax for a pointer? Okay, first of all, we have to define, just like in normal variables, which one is the data type for that pointer. Okay, so the pointer is going to point to a variable, and we have to define here what's the type of that variable that we are going to point to. In this case, it says integer. Okay, we're pointing to an integer. Okay, so what's the next element for creating a pointer? The asterisk sign, and then the name of a pointer. So we have data type, we are point to, then the asterisk, denoting it is a pointer, then the number of the pointer. So we have here a pointer called p, which points, because it is a pointer, to an integer variable. Okay. Okay, let's continue. This one will be the example of a pointer called ptr, pointing to a char type. Okay, a char variable. This one points to a double variable. Now let's do the pointer definition. That is, we are going to assign a value. Remember that since it is a pointer, it will not take any all of the values, but it actually only accepts addresses of variables. Okay, so it is important that it will receive only the address of the same type that we defined here. So for instance, if we have this integer a, we are going to define a pointer to an integer. Okay, this will allow us to actually point to this integer because it is a pointer to integer. So the type also matters. The type of the variable and the type of the pointer must match. Now, to give it a value, we are going to use this ampersand sign, which is the address operator. It means that if you place it before a variable, it will find what's the address of that variable. In this case, ptr is assigned the value of the address of a. Okay, so this is how you give a pointer a value, by assigning the address with this operator of the variable that you want. Okay, now the actual use of using this data type that we are pointing to is because, okay, this is the pointer and it has the address that it's pointing to, okay, to the variable. However, if I defined this pointer to be pointer to an integer, it will know the following, that this one is the address. Okay, so it will point to this address. However, as you can see, we have here 4 bytes. It means that it is an integer that occupies that size in memory. So this is the address, and this one will uh, depending on what I defined in this pointer here, the data type will tell me from this how big is the data starting from that point in memory. Okay, so the next one will be the case when I have a byte long data type. Okay, it's the same address, however now the size is just 1 byte. Okay, so that's why we have to define also the data type that we are pointing to with our pointer. Okay, now I'll tell you a good practice to follow when using pointers. Uh, when you don't assign in the very beginning um, an address to your pointer because you don't know, or you still have to wait some time or other processes in your program to um, tell you what the address is. The best practice is to initialize the pointer to null or zero, which means that it will be interpreted as it is not pointing to anything. Okay, to avoid any undesired jump to other address that we may not be authorized to use. Okay, so this will cause our program to freeze or crash. Um, okay, now we're going to get to know some other details. This one is it's a generic special type of data, which is void. Uh, we can use pointers to void in this case to allow us to um, store in that pointer to void any data type, any address of a data type that we want. What I mean is actually, okay, void will accept addresses from integer, char data types, float, double, etc. So you do that if you want to have a generic pointer that can receive any of these addresses to any data type, in case you don't know what's the type of data that is going to return any in any case of your program. Okay, so for instance, as you can see here, this void pointer ptr was assigned the address of an integer, which is this one a, but also the address of this one, which is a char data type. Okay, this may be useful over the time. Now, how to handle pointers. We are missing just the last part. First of all, we learned how to create them. So uh, now you know the syntax is the type of data that we are going to point to, then the asterisk, then the name of your pointer. Then to give it a value, to assign some value to your pointer, you have to use this address operator before the data type that you want to uh, assign the address to this pointer. Okay, so the final operation is the when you access the data that you are pointing to, because we are pointing to a, the variable a. However, we want to manipulate this value of 15, which concludes all of the usage of the pointer. So you access that value by using this asterisk before the name of your pointer, which is called uh, the referentiation of your pointer. So this means that you are placing this asterisk before the name of your pointer to access the value that it points to. So ptr points to the variable a. Okay, I point to the address of a. However, I want to use the value contained stored in this address. This is how you do that. Okay, asterisk and the name of your pointer. So we have here two examples. In this sentence, where in this statement we are using printf to print the value of ptr. Remember that ptr is a pointer, so the value it contains is an address. So it will print an address. However, in this other statement, we are printing also. However, the value here changes because we are printing ptr, but being dereferenced, okay? So we are not pointing the address, but we are actually extracting the value within this address pointing to by PTR, okay? So if you want the address that PTR is pointing, you use just PTR. If you want the value, you will use this the referentiation operator, okay? Say for instance here, we created an integer b and we assigned the value of, in this case, PTR asterisk. It means the value contained in this address, here, which is 15, because PTR is pointing to A, which contains the value of 15. This asterisk means we are extracting the value contained here in this address. So it will be 15 plus 5 equals to 20. This is the result that we are going to print. So remember this, PTR has the value of an address. However, if I use this referentiation in PTR, I will find the value that is in this address that PTR contain, okay? Because what I actually want is to control data. Okay, we're finished, so let's do our first practice. Okay, now we are also in this online gdb.com simulator. We select the language and let's start. So first of all, I will create an integer variable named a with the value of 15, and then I'm going to create a pointer to integer. So remember, how do I create a pointer? The data type that it points to, then followed by an asterisk, and then the name. I'm going to use the name p, and I'm going to assign it the address of a, which is an integer, okay? A, address of a. All right. Now I'm going to print the value here with printf. So comma, and remember that in order to use printf to print the value that I want, which is 15, I'll have to pass the value of 15. So remember that the value of p now is not 15, but it's actually the address of a. So to get the value inside the integer a, I will have to use the reference operator, okay, in order to get that. If I don't use it, I will get obviously the address. However, since it is not a normal number, but it is an address, I will have to use the format specifier %p, and I will have the address, which is this long hexadecimal number here. However, what I want actually was the value I actually wanted. So printf and then the integer value, but for that purpose I will need to dereference the pointer. So now you have here the address and the actual value within the address by dereferencing it with this the reference operator, you know. Okay, now let's do the void pointer. So now I'm going to use a different pointer. So let's create void, which is the type, then pointers sign, and let's give it a different name, PTR. Okay, now I'm going to use PTR as the pointer to access the value of 15. So remember, what I have to do is, now that I have PTR, I will assign the address of a. Okay, is everything ready? Now let's see here, PTR and the reference PTR. Okay, let's run it. Okay, I have an error here. It says invalid use of void expression. Well, since it is a void pointer void data type. As you can see here, this one is expecting for a for an integer. So what you will need here is actually a pointer to integer, just like before, in order to complete this operation, because it expects a integer value. So uh, the workaround for this is actually doing something that is called a typecast, which means that I place in this parenthesis the type that I want my program to interpret the following datum that I have here. So this is the way that you typecast something in C. What does that mean? Since this is a void pointer, it will confuse our program. It says, okay, I'm awaiting here a integer type, but this one is actually returning a void pointer. So this is weird. So what do? I typecast. But for that purpose, I will need to use this parenthesis. Inside, I place the data type that I want my program to interpret when I'm returning here, and then the actual datum. Okay, so the actual datum here is ptr because it's the name of our pointer. Then I place here this parenthesis of my typecast, and remember what I want this to be interpreted as. I want to be this one to be interpreted not as a void pointer, but actually as a pointer to integer. Okay, and then after all of this, I will need to also dereference it. So we are using here two operators: the dereferentiation operator and the typecast. Okay, so it turns out that these two operations have the same hierarchy. Okay, so they also are read from right to left. What does that mean? That they take the right operand just aside them, and this will mean PTR is applied the typecast, so it is interpreted as a pointer to integer, and then after all of this, which is on the right side of this the reference operator, will be dereferenced. So I read PTR, applied this operation, and then applied this other operation, and then run it. As you can see, I get new addresses in memory because the program runs again, and it is assigned different areas in within the memory. Okay, however, the value is the same here. Okay, so remember, for both pointers, you will need to do the typecast in between the reference operator and the name of your pointer. Okay, don't forget it. Okay, now let's talk about pointer arithmetic. Um, as we already reviewed, a pointer contains the value of a address in memory. Okay, so if you apply the operations like increment, decrement, or addition or subtraction, you will be able to um, alter the position, the address that that pointer points to at a given time. So for instance, let's say that your pointer points to the first position here in this array, and you perform the operation of increment. So remember that the pointer means that it has an address. So if you increment here, what you are actually incrementing is the address of that pointer. So it will increment to the next address in memory, and so on and so forth, depending on what the operation is of decrement or increment. Okay. Also, you can do additions by any number you need to displace the actual position of the pointer, how many places you want, okay? Um, as much places as you want, you can move your pointer according to this simple arithmetic of increments and addition and subtraction. Also, there is other operation that you can perform, which is comparison, and you can compare your pointer to addresses. So you compare the value of your pointer, which is an address, against another addresses. For instance, let's review this one. It says PTR if PTR equals to the address, because it is the ampersand operator, the address of score 7. So score 7 will be this one, the last in this array, okay? So what does that mean? What does that mean? Let's say, for instance, that I am changing or incrementing this PTR one place at a time. So, for instance, let's say that I'm doing a single increment, and it's currently in this position. So it will be incremented one position at a time, and whenever this comparison is true, so whenever PTR gets to this address, this condition will be true because now PTR equals to the same address here, okay? So we have this basic arithmetic for pointers. Now let's review this next expression. Score, when you have the name of your array and this index, which is in square brackets, it means the value stored in this position. So score and this index 7 means the value that is stored here, okay? However, if you apply the address operator, you don't mean what's the value inside here, but actually what's the address in which we have this value. So in this position 7, what's the address of this position 7, okay, by placing this operator. So now, yes, yeah, let's review this in a practice code. Okay, now we are going to do a practice code for arithmetic operations in pointers. So first of all, I want you to bear in mind that an array is considered internally by C language as a pointer. So as you can see here, only the name of this already defined array of integers it's taken as it is a pointer. So A means now the address of the first position in that array, okay? So A means the first address in which this number one, this first value is located, okay? Okay, I'm going to show you that I'm not lying. So let's say, for instance, here that let's use A as a pointer, and let's dereference it. Okay, if I dereference it, what do we expect? Okay, we will have to get the first value, which is here 1. Okay, as you can see, I'm not lying. Also, if I move, because it is already a pointer which points here, if I add 1, it will move to the next position because it is already an address. Which address? The address of the first element. So if I add 1, I will be in the next address here. Okay. However, if I dereferenced this new address, which I moved forward, I will find the following value, which is 2. Okay. As you can see, I'm not lying. So this is something important for you to bear in mind. The this array name is considered a pointer to the first position here, the address of the first element. Okay, now that we know that, I'm going to create pointer to an integer, and I'm going to call it b, and I'm going to since uh, this matrix this array A is already a pointer, which means that it is an address, it contains an address, I can do the following. Remember that I told you that we needed this ampersand sign, which is the address operator, to assign the address. Okay, this is b pointer to integer. Okay, and I'm assigning the a, and here I'm going to the references. So since it is already uh, a pointer, it has already an address, so I don't have to apply 2 times the address, because as I told you, it already a already contains the address of the first element, so it doesn't need to be applied the following the ampersand sign, the address operator, because it will cause any error, some errors. Okay, so let's see if we get what I wanted. Okay, yeah, it means that b, it's pointing to a, which is, you know, the first position, the first address in this array, and we dereference it, so we get the value in that position, not just the address. Okay, now we are going to do some pointer arithmetics. As already told you, we can let's start subtracting now. So in order to subtract, remember that as a rule of thumb, we should not move forward or beyond this maximum value, or backwards beyond this first value within the array. Okay, so what I'm going to do now is to give this b pointer the address of a what, a, this is the a0, a1, 2, 3, and 4. So now b is pointing to this address in this array. Okay, now I'm going to use an arithmetic by which I'm going to subtract 3, so it's going to move backwards by 3 positions. So 1, 2, and 3. The value should be 2. Okay, because we are the reference it. We are first moving b, which was initially this in this position, a4. We are moving backwards by 1, 2, 3 positions, and then with the reference that the value in that position, and we print it. Okay, let's run it. Here we have 2. So you can add or subtract according to what you need. What did happen? What happened here? Oh, okay. Remember that it will decrement, but in the next round. So here we have, it is decremented before being used. Okay, so now we have, okay, now let's do the comparison. Okay, you can remember, you can add, subtract, increment, or decrement, but always consider in which position you are, so you don't go beyond the boundaries of this array. Now I think I told you. Oh, okay, now we are going to move, yeah, 4. Let's place the 4 here. So what we are going to do now is to create a counter variable, which is integer e. It starts in 0, then until this integer I, until I is less than 5, keep incrementing. So what we're going to do now is b plus assigned pointer b with the address of a0, which is actually a. So I don't need to write all of this a. So it's now in this position. I'm going to move 1, 2, 3, and 4. Okay, so yeah, so it will print a value of what is this? B plus I, sorry. Okay, so it will be printing the pointer by moving 1 unit each time. Okay, it starts in 0, then 1, 2, 3, 4, 5, because it's my pointer. It moves in all of these addresses, and we will get the values because we are dereferencing it over time. So we have here 1, 2, 3, 4, 5. Okay. I can do this with the while also. Alright, finally for the comparison, we will do the following. Here we have the pointer b, and we assign it the value of a, which will be the first position here in this array. And then we start a while loop in which we will iterate as long as b, which is this pointer, has an address which is equal or lower to that of a index 4. So remember, a index 4 is this one, and we apply the address operator, so this will be the address, the limit address, and as long as the pointer b points to an address which is equal or lower, we will repeat this one, which is printing the value, the referencing the pointer b, which will be all of this data in every of these adjacent positions. Okay, as long as it keeps incrementing. So it's doing the comparison and incrementing. Okay. So as you can see, it will print all of the values from starting from the position 0 up to 5, in which this address will be incremented again, and for the next time it's higher than this position here, so it terminates the loop by comparison of these two addresses, the one contained or stored in the pointer b, and this one in this position. Okay. Alright, now it's time to review the concept of pointer to pointer. As you can see, a pointer can indirectly allow us to access the values of a variable pointed to by this pointer. Okay. However, we can place different pointers to point to the same variable, like in a chain. So, for instance, um, the way that you define a pointer that points to another pointer, which actually points to a variable, is by placing several asterisks here. Remember, this will be the normal pointer that we already reviewed, which is the type of variable that we are pointing to, then the asterisk and the name of our pointer. So the second one here in this line says that it points to an integer also. However, it has two asterisks. So it actually means that it's going to be a pointer that points to another pointer. That's because it has an additional asterisk. However, all of these pointers must be of the same time, no matter that one is a pointer to a pointer to a pointer, or actually a pointer to the variable. All of them must be of the same time, as you can see, variable and all of the pointers. So here we have our pointer to pointer. So it says it is a pointer called p, which is a pointer to integer. So the first pointer is going to be this one, ptr, and the second pointer will be pptr. Okay. Now let's define them. Let's give them a value. So PTR is assigned the address of A. Okay, so this is the first one, which is pointing to the actual variable. And PPTR is going to be assigned the address of PTR. So what does that mean? That PTR points to PPTR points to PTR, and PTR points to A. Okay, so we get to the value of A by starting from PPTR to PTR and then to A. Okay, so if I dereference this PTR, it means that I'm going to access the value in A, okay, which is 15. However, if I dereference 2 times, I made a mistake here because it should be PPTR, so sorry for that mistake. However, uh, let's suppose this PTR is actually PPTR, this one. If I dereference 2 times PPTR, what I'm actually doing is accessing the value of 50 because in the first dereference operator, I'm going to access this one, which is PTR, okay. However, if I dereference this for the second time, now from PTR I'm going to go to A, where I'm going to find the value of 15, okay. So let's say for instance this is the address of PPTR. Let's suppose, I mean, it is a pointer that points to a different address, and this new address contains another address which actually is the address of the actual value, okay. 4 bytes, we have here an integer. So the first one will be PPTR, okay, which is what? A pointer to a pointer. So it has the address of a pointer. This is the address here, and this is the new pointer, which is going to be PTR, which contains the address of the actual value, okay. So it is like a chain. PPTR is this address. If I do reference by the first time PPTR, now I have PTR, which is the second pointer. And if I do reference for the second time, I mean, all I have to do is this one, okay? Not all these intermediate steps, but actually I'm going to reference in just a single statement. I get to the actual value here, okay? Okay, I guess we're finished. Now let's do the practice code. Okay, now let's do the sample code for pointer to pointer. First of all, let's start again with an integer variable. Then pointer to integer. Let's call it P. And let's assign the address of A. Okay, and now the pointer to integer, which is PPTR. And let's assign it the value, the address of P. Okay. Okay, so what do we have here? We have an integer variable called A. One single pointer, that P, which points to A, value of A, and we have also the pointer PPTR, which points to the pointer P. So PPTR points to P, which points to A. Okay. Okay, now let's print the values. We'll have the value is an integer, so we will need to, if we used the referenced P, it will print the value of A. It's pretty much obvious, which is 15. However, if we use PPTR, we will need to dereference more than just one time, so it will need this to double the reference operator. Okay, what does that mean? It will go through P, and then it's going to this P from P to A, okay? Thus, it will find the value of 15. All right, this is the usage. Now, let's illustrate here with the printf function the different addresses in memory. Okay, what we are going to do here. Uh, so let's print the address of A. We'll need new line. Okay, the address of A. Then the address of B, and then the address of PPTR. What else? All right, let's run it. These are the different addresses. So you know this is the address, the last one, which is next to 15, which is this value that it's pointed indirectly by PPTR through the pointer P. This is the address for the PPTR pointer, and that pointer points to the next address, which is the pointer P, PPTR P, sorry, which is this one, and then this address of this pointer points to the final address, which is the address of A, in which in which 15 is stored. Okay. Okay, now let's try this last modification. We will have the address of all of this data, the two pointers P, PTR, and P, and the integer variable A. Okay, but we also we are going to check the values inside P and PPTR, which are, as you know, in P will be the address of A, and in PPTR will be the address of the pointer P. So, as you can see, the value in A is 15. These are the different addresses. The address of A is this one, 3204. This address of P is 3208. PPTR 3210. Okay, so as you can see, P, the value inside P is 3204, which is the address of A, as we expected. And PPTR is 3208, which should be the address of B. Yes, okay. Alright, for the last topic of this video, we are going to review the concept of array of pointer. Okay, a normal array contained, as we saw previously, in adjacent addresses in memory values of the same type. So I basically had the name of the array, and in this square bracket I will place the index, that is the position in this within the array that I want to access. However, in this one, which is an array of 8 elements, however, now the datum the data type contained in this array is not actually integer, but it's a pointer. So what does that mean? It means that in every position it does not have the actual value, but it will have the pointer to that value. So it means in every position we have the address in which the actual value is located, is stored. So for instance, here we have this address, which is 03. So if I go to 03 in that position of memory, I will find the value 500 Yeah, 546. Uh, for the next position, the pointer is the address of is 7b, just like in here. So if I go to that position memory, I will find the actual value, and so on and so forth. All of these um, elements. Okay, so okay, uh, all of these positions within the array contain the address. I mean a pointer to the actual value. Okay, so this is what I array of pointer means, that it contains the pointers to the values here. Okay, not directly the actual value. And remember, score and this index means the element within this position in the matrix, in the in the array. Okay, so score and index 7 will mean that this is the element inside here, which is what? An address to memory, okay, because it is a pointer. So it contains a pointer. However, I need the actual value most of the time. So taking that into account, I will have to apply the following operation. I will have to dereference the content within this position. So I have an address here because it is a pointer. It's an array of pointers. However, if I dereference it, I will have the actual value because I'm going to say, okay, this is the address, dereference it, and I will get now the actual value. Okay, this is the way of working with this with such arrays. Remember that an array is considered a pointer per se in C language, so it means that the name here, score, is already a pointer that is pointing to the first position, the first address in memory of this first element within the array. Okay, so I can use also the pointer arithmetic to move forward or backwards if I wanted. And how do I operate to get the value there? Actually, I can also dereference it. Okay, because remember, it is taken as a pointer, so score is already an address, and I'm not using now this index, but I'm actually using this, taking into account it is considered a pointer. So I am dereferencing and I am going to have here the value. Okay. All right. To finish this part, we will give another vectorial representation of the same array of pointers. As I already told you, the elements within this array point to the actual location where it is the actual value that we need. Okay, so imagine that this array and all of these block in memory are in the same block of memory. So for instance, uh, this array might be before these positions in memory or after. Okay, but all of them are part of the same block of memory, the memory allowed or granted to our program. So we will have here the pointer to the actual value. Here it's the address 03. So we're going to go to 03 and find the actual value there. Okay, the same for all of the other. Okay, 05, 05, and this value, and so on and so forth. This is what actually means this array of pointers that you have inside, not the actual values, but pointers to the actual address in which is the actual value. So remember that you will have to use the reference operator to get the actual value. Okay. Now let's go and do the practice code. Okay, now for the array of pointers, we are going to fill uh, an array of pointers with pointers to the actual values in a normal array. So let's start by creating pointer to int array. which is going to be called B, and then just as I told you, we are going to place here pointer to integer, pointer to integer, pointer to integer, five of them. Okay. No, this is really bad. Okay, now in each of these positions, I mean all of the elements in this pointer array of pointers to integers, we won't find the actual number, but we will find the pointer. I mean, you know, the address in which we can find the actual number. Okay, so here we have an address that points to the actual number, a pointer, if you want. Okay, so how do we do that now? Okay, we create first this array of pointers to integers named b, with 5 positions, 5 elements, and now we're going to use the for loop. Oh, sorry. Okay, let me see. Okay, yeah. Now we're going to create a counter variable, which is int I. Let's initialize it with 0, then until I, as long as I is less than 5, will be incremented in each iteration. What do we do in each iteration? We are going to fill the different elements in B with the elements of I mean A. Sorry. Okay, so what's wrong here? Remember that B will accept only pointers because it is an array of pointers to integer, so it will not accept the values, normal values. So I will need to use the address operator. Okay, so in this way we are going to assign the address of this first position to the first element here, and so on and so forth. Okay, so let me see, let's just say, yeah, the address, yes, and then whenever we're finished, we are going to print the contents of this array of pointers to integer. For that, we will use integer I equals to 0, less than 5, I plus plus. Okay, we'll use the printf now, and since they are integers, we will use %d new line, and then how do we do that now? We'll have to use b, and remember that since all of them are pointers to integers, we will have to dereference each of them to get the actual number. So, oh, what's the error now? Okay, let's see. It says 16, line 16. Is neither an array nor pointer nor vector. And 11 and A. No, this one is an error. Okay, this was the only error. I had an equal sign here. Okay. Okay, now the last and second example for this array of pointers will be an array that contains pointers to characters, to a char type. So we're going to use char pointer. Then let's give it a name, and we are going to use 5 elements. So pay attention to what I'm doing here. Okay. Now in each of these elements I'm going to place not just a single character, but actually a string of character, which is called as string in C language, which is the following. Say for instance John Smith. Oh, okay. John Smith, comma, let's say now Josh Smith. So now, Margaret Smith. What is 1, 2, 3, 4, 5? Okay. Let's say now, where else? Sorry. Let's say Alan, and let's say Elton for Elliot. Okay, we have 1, 2, 3, 4, 5. Okay, as you can see, each of these elements does not contain just only one character. So how do I do that? Actually, in C, pointer to character will mean that I will give the pointer to the first character, in which could be an array of several characters. I mean, this first pointer to the first character will have trailing characters, and it will start printing all of the characters until it finds the end. In this case, as you can see here, is marked by the double quotation. So we have an array, as I told you, that does not contain here the actual data. It contains just the pointer, and in this case the pointer to just the first character or letter. Okay, so we have John Smith in this fashion somewhere in the memory, and we have John, sorry, all of them in adjacent memory addresses. Okay, so what I actually have here is just a pointer, okay, and it points to the first one, and same for the rest of the names. So we will have something like this. So on and so forth. And as I just as I told you, in our real array, we have just the pointer to that character. Okay, so we have the address to the first one, and same for the rest of the array. However, the actual characters are in other area of the memory that is possible, that is accessible via these pointers. Okay. Okay, so now let's just print the names, since I already placed them there. So this is actually what I'm telling the computer is, okay, I want all of these characters stored in memory, okay, in some space of memory. But here okay, my computer will allocate this space, will place all of these letters, characters of the name somewhere in the memory. However, this will tell me where they are via this actual pointer to character. So this will tell, okay, the first letter of this is in that particular address, and then it will print the next and the next and the next until it's finished. And same for the rest of them. Okay, that's something that happens, and that's why pointers are useful, because we don't know the computer what memory address in the computer will be used for that purpose of storing these letters that we ordered here to our program. How, but however, the program will uh, do this task and then will store or will save what's the address of the first character, and we'll save it here. Okay. Okay, now let's do the following. Um, we will need percentage %s, which means string, to print these names, okay? These elements in each position. So we will use name, then the index I, and this format, okay? Now let's run it. And here we have, this is how it works.